Today we're going to be looking at 8.6 again with some useful theorems. There are a few things that we didn't get to cover in class the other day that I want to cover with you guys today. I'm going to go over some examples that we may have done in class, but I feel like they were a little bit tricky, so we'd like to hit those again. So we're going to start with an example where they give us one root of the function and we're going to solve and find the other roots. So we're going to solve x to the fourth minus 6x cubed plus 6x squared plus 24x minus 40 equals 0. And the root that's been given is 3 plus I. So hopefully right now there's bells going off in your head because you're remembering, oh, Mrs. Fuller told us that imaginary answers always travel in pairs. So if they give us the root 3 plus I, we know that there's also another root there, 3 minus I. So because this is a fourth degree function, we know there should be 4 roots. They gave us one imaginary root. We know that they travel in pairs, so that means we actually have 2 roots. So of the 4, we have 2. We're going to use synthetic division twice, once with this one and once with this root. That will take us down to an x squared function. Then we'll use what we know about solving x squared functions to find the other 2 roots. So let's begin. We're going to put 3 plus I in the box, and then we're going to make our coefficient row. Remember, we want to look for placeholders, so we've got 4, 3, 2, 1 constant. We don't need any placeholders, so we're going to make our coefficient row. 1, negative 6, 6, 24, and negative 40. Remember with these complex roots that they can get a little bit wide, so I'm spacing these out maybe a little bit wider than I normally would. We're going to go ahead and do our synthetic substitution or synthetic division. We're going to bring down the 1, and then we multiply. Then we're going to add. Real parts get added with real parts, imaginary parts with imaginary parts. So negative 6 plus 3 gives me negative 3 plus I. Then I'm going to have to multiply. I'm going to put a box around that. 3 plus I times negative 3 plus I. We're going to FOIL that. So 3 plus I times negative 3 plus I. We want to be really careful with our signs. So we've got negative 9 plus 3I minus 3I plus I squared. So negative 9 stays. Positive 3I minus 3I, those cancel each other out. And then remember, I squared is equal to negative 1. So this becomes plus negative 1. Negative 9 plus negative 1 gives me negative 10, and that's going to go over here. So now I add 6 plus negative 10 gives me negative 4. Then I'm going to have to distribute negative 4 times 3 plus I. It's good to have a space off to the side where you can do some of this work. So we've got negative 12 minus 4I. That's going to go in here. Negative 12 minus 4I. Real parts with real parts. So 24 minus 12 gives me positive 12 minus 4I. And then I'm going to have to FOIL one more time. 3 plus I times 12 minus 4I. So 3 plus I times 12 minus 4I. So we're going to FOIL this. We get, I'm going to go down here, 36 on the outside minus 12I on the inside plus 12I, and on the last minus 4I squared. So again, 36 will stay. Negative 12I plus 12I, those cancel each other out. And then I squared is equal to negative 1. So we have negative 4 times negative 1. Negative 4 times negative 1 becomes positive 4. So 36 plus 4 gives me 40. And what do you know when we put that up there? We get 0. We were expecting that because they told us that this is a 0 of the function, which means that we should get 0 for a remainder. Now, we started as an x to the 4th function. We've done one layer of synthetic division, so we've come down 1 degree. So just as a reminder to ourselves, this row would be a cubic function. But we have another imaginary root, so we're going to do synthetic division again. Just scaffolding off here, we're going to just build another layer and do our next layer of synthetic division. So now I'm going to use 3 minus I outside the box. I'm going to bring down, and I'm going to go ahead and start. So I've got 1, and then I'm going to multiply 3 minus I. I'm going to add real part plus real part cancels. Imaginary part plus imaginary part cancels. Then I'm going to multiply by 0. Well, anything multiplied by 0 is 0. Add. Then I'm going to multiply here. I'm distributing. So I've got negative 4 times 3 minus I. That's negative 12 plus 4I. Remember, I just stays I. Nothing happens there. Sorry. So we're going to have negative 12 plus 4I. Negative 12 plus 12 cancels. Negative 4I plus 4I cancels. And there's the 0 remainder that we were expecting. We were at a cubic function here. We've done another layer of division. So now we're down to an x squared function. So now this is our coefficient row for our new x squared equation. So we're going to have 1x squared plus 0x minus 4 equals 0. Now we're going to solve. You have a couple of choices here. This is a difference of squares, so you can factor and solve. A difference of squares would factor in x plus 2, x minus 2 equals 0, and then you would set each factor equal to 0 and solve. Or you have another option here at x squared minus 4 equals 0. You could add 4 to both sides, and you could take the square root of both sides. Remember, when you're solving by taking the square root, you always have 2 answers, the positive and the negative answer. So the square root of 4 would be plus or minus 2. Same 2 answers that we get from factoring. So you choose whichever method you prefer. So now we're going to list the roots for this equation. Remember, we were starting out with 3 plus I, that was given. Then we know that imaginary numbers travel in pairs, so 3 minus I is understood. Then we solved and we got positive 2 and negative 2. So those are the roots for that equation. 3 plus I, 3 minus I, 2, and negative 2. All right, let's try one more like that. So same kind of example. We're going to find the remaining roots if we have x to the 4th plus x cubed plus 6x squared minus 14x minus 20 equals 0. If 2 of the roots, so this time they're giving us 2, are positive 2 and negative 1 plus 3i. Now, again, this is a 4th degree function. The degree of the function tells us how many solutions it should have. So a 4th degree function should have 4 solutions. Here they've given us 2. 2 and negative 1 plus 3i. But you should be hearing those bells in your head. Whenever you have an imaginary solution, you know it always travels in pairs. So they've also really given us negative 1 minus 3i. So of the 4, they've given us 3. We're going to do synthetic division with all 3 of these, taking it all the way down, and then we're going to solve. So I'm going to start with the real solution that they gave us first. I'm going to use the 2. So I'm going to make my coefficient row. I've got 4, 3, 2, 1 constant. I don't need any placeholders. So I've got 1, 1, 6, negative 14, negative 20. I'm going to bring down, and then we multiply, add, multiply, add, multiply, add, multiply, add. All right, because we know it was a 0 of the function, we know that we should get a 0 remainder. and then it was an x to the fourth function. We've done one layer of synthetic division, so now this is taking us down to an x cubed function. Next, I'm going to tackle this first imaginary. So I've got -1 plus 3i. I'm just going to build right on to the coefficient row that I already have. So we're going to bring down the 1, and then we're going to multiply. -1 plus 3i. 3 minus 1 gives me 2 plus 3i. Then I'm going to have to multiply. So I have -1 plus 3i outside, and I'm multiplying by 2 plus 3i down here. So I'm going to have to FOIL. So I've got -2, -3i, +6i, +9i squared. So -2, -3i, plus 6i gives me 3i. And then I have 9 times -1, because I squared equals -1. 9 times -1 gives me -9. -2 minus 9 is -11. So I have -11 plus 3i. That's going to go back over here. It's getting a little tight. I didn't leave myself very much space. -11 plus 3i. All right, so 12 plus -11 gives me 1 plus 3i. Then I'm going to multiply the outside by this answer. I have to FOIL again. -1 plus 3i times +1 plus 3i. So FOIL, we've got -1 minus 3i plus 3i plus 9i squared. So the -3i and the +3i cancel, and then 9 times i squared. Remember, I squared equals -1, so I have 9 times -1. That gives me -1 minus 9, which equals -10, and that's going to go back over here. -10 plus 10 equals 0. Again, that's what we were expecting. We've done one more layer. Excuse me. So this comes down to an x squared function. Okay, now we're going to use the other imaginary solution. That's a pair. So we're going to use -1 minus 3i. All right, so we're going to bring down, multiply, -1 minus 3i. 2 minus 1 is 1. +3i minus 3i cancels. Then I'm multiplying by 1 again, so I have -1 minus 3i. 1 plus 1 is, 1 minus 1 is 0, and 3i minus 3i is 0. Now I went down all the way to an x function. This is a linear function, so I've got my coefficient row is 1x plus 1 equals 0. I just have to solve that. I'm going to subtract 1 from both sides, so x equals -1. So my roots, I have -1 that I solved, and then I have all of these that were given. 2 and -1 plus 3i were given, and then we remembered that imaginary numbers travel in pairs, so -1 minus 3i was also given. 1, 2, 3, 4 roots, fourth degree function. The degree tells you how many roots you're going to have. All right, now we're going to switch gears a little bit, and we're going to talk about how you can predict what type of roots a function is going to have. And there's something called Descartes' Rule of Signs. So this is from your book. On page 378, Descartes' Rule of Signs. Let p of x be a simplified polynomial with real coefficients and terms arranged in decreasing degree of x. The number of positive real roots of p of x equals 0 equals the number of variations of sign of p of x, or is fewer than this number by an even integer. The number of negative real roots of p of x equals 0 equals the number of variations of sign of p of negative x, or is fewer than this number by an even integer. It explains it a little bit more up here. what we're looking at is when you have the function, we're looking how many times does the sign change from term to term. So this is a positive term and this is a negative term. That's one sign change. Negative to negative, that's not a sign change. Negative to positive, that's changing sign, so that's the second time. Positive to negative, that's changing sign, so that's the third time. This one has 3 sign changes in p of x. That means it would have 3 positive roots. Or it could have 2 less than that. It could have 1 positive root. The other roots would have to be negative. So we're going to look at that. Sometimes Descartes' rule gives complete information about the number of roots of various kinds. So for this one, it has 1 variation in sign. So it has exactly 1 positive real root. When you plug in negative x and look at how many times it changes signs, it also has 1 variation in sign, so it would have exactly 1 negative real root. But it's supposed to have 4 roots total, so if it has exactly 1 positive and exactly 1 negative, that means that the other 2, to give you 4, would have to be imaginary. So let's look at how you would figure this out. All right, we're going to list the possibilities for the nature of the roots. So, list the possibilities for the nature of the roots. So we're going to be telling, are they going to be, how many are going to be positive, how many are going to be negative, and then if there's leftovers, those would be imaginary. So the function we're going to look at is p of x equals 5x to the 4th minus 3x squared plus 6x minus 10. So first of all, we need to decide how many answers should this have? How many roots should this have? This is a 4th degree function. So 4th degree, that tells us there should be 4 roots total when you count them all up. All right, now we're going to look at how many times it changes sign. So p of x starts positive and then it goes negative. So that's 1. Then it goes from negative to positive. So that's 2. Then it goes from positive back to negative. So that's 3. 3 sign changes is 3 positive roots. Now, when that happens, it can also be an even number less than that. So I'm going to make a little chart. We've got positives, we've got negatives, we've got imaginaries. Because there are 3 positives, and we know that imaginaries always have to travel in pairs. So we can never just have 1 in the imaginary column. It always has to be an even number of imaginaries. That means that here we would have 1 negative and no imaginaries because it has to, remember, it has to total 4 over here. If we go down by an even amount, we'd have to do 3 minus 2, so that would give us 1 here. Then we could have 1 negative, and that could give us 2 imaginaries. So that's the other combination that we could have. If you look at p of negative x, that basically means you're just going to plug negative x in place of x, and then you're going to count the sign changes. So if we go back to the function and plug in negative x, we have 5 times negative x to the 4th minus 3 times negative x squared plus 6 times negative x minus 10. A negative number to the 4th power is going to be positive. A negative number to the 2nd power is going to be positive. This is going to be a negative, and this is going to be negative. So we have 5x to the 4th minus 3x squared minus 6x minus 10. We're counting sign changes or variations. So it starts positive and goes negative. That's 1 change. Then it's negative, 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 negative. No more changes. That means it can have 1 negative root. When you put in a negative x, you count the number of sign changes. That tells you how many negative roots you can have. So these are the possible combinations for this particular function. It could have 3 positive and 1 negative, or it could have 1 positive, 1 negative, and 2 imaginary. Okay, let's look at a couple more examples of how to do that. So we're doing the same thing, new function. If we have 2x to the 4th minus 3x minus 1 equals 0. We're going to count the number of sign changes. So it goes from positive to negative, so that's 1. Make my little chart here. So it's got 1 sign change on the positives. Let's see what happens on the negatives. If we plug in p of negative x, we're going to have 2 times negative x to the 4th minus 3 times negative x minus 1. So negative number raised to an even power becomes positive. But then negative 3 times negative x becomes positive 3x. So here we have positive to positive, no change, positive to negative, 1 change. 1 change in a negative function is 1 negative possibility. Again, this is a 4th degree function, so we know it needs to have 4 total. If 1 is positive and 1 is negative, that means that the remaining 2 are going to be imaginary. All right, one more. If we have x cubed plus x plus 5 equals 0. Make my little chart. All right, in the first one, we've got positive to positive, positive to positive. So there are no positive sign changes. No positive answers. Let's try negative. If we put in negative x cubed plus negative x plus 5 equals 0. Well, a negative number cubed stays negative, and then positive times negative is negative. So for this one, from negative to negative is no change. From negative to positive is 1 change. 1 change is 1 negative solution. Well, how many solutions can this one have? This is a 3rd degree function. This one needs to have 3 total solutions. I have 1, and I have some space for imaginaries. Imaginaries always travel in pairs, so at the minimum, I have to have 2. If I have 2 imaginaries and 1 negative, that would give me a total of 3. So I have 2 imaginary solutions and 1 negative solution for that one. Okay, one more thing to show you. Oh, actually, that's the end. That's all I have for you for this one. The next lesson will be 8.7. Hopefully this is helping to have the videos to watch. You can post questions or comments for me on the video on our Google Classroom site. You can also email my school email address, and I will answer those questions for you. My office hours are Mondays and Wednesdays from 10 a.m. to noon, so that's when I check my emails. So send me those questions and post those comments if you have questions so I can help you. You do have a take-home test in your packet this week, so hopefully you're studying and you're doing all the assigned problems so that you can be prepared for that test. You guys are going to do great. I'll see you soon. Bye.